Okay, we're going to talk about 4 advanced milling calculations. That would be chip thinning, and you'll see a little diagram down here. And you'll see ball nose chip thinning, which is going to be a true calculating of effective diameters based on depth of cut. 45-degree lead angle is a thinner chip. It's actually a 30% more efficient cut. And then toroidal, where it's kind of like the ball nose, but we're talking about big corner radiuses or insertable button cutters with the depth of cut, calculating the effective diameter. So let's go into the ball nose, and we'll pick that 3/4 inch end mill again. Okay, and then we'll stick with 3 flutes and 500 surface feet at 3,000 chip load. But as this diagram shows, with the depth of cut, from the bottom up to the depth of cut, it creates a new true cutting diameter or effective cutting diameter. So let's put a depth of cut of 25 thousandths and calculate this, and it shows us that the true diameter is 269 thousandths, not based off of the 3/4 inch diameter tool. Now, with that surface feet of 500 at this diameter, the RPM now is 7,100 RPM, and with the chip load and number of flutes, we're going almost 64 inches a minute now. Okay, this has to do with the effective cutting diameter based on depth of cut. Okay, there's a similar one for chip thinning for radial width of cut. If we're using that 3/4 inch end mill, 3 flute, 500 surface feet, and we'll do a feed rate of 3 thousandths. Now, with the width of cut being less than half of the width of the diameter of the cutter, then what's going to happen is this thing is going to rub and it's not going to cut. Because if it was coming in at this calculation of 3 thousandths, when it gets linear, it's going to be something less than that. So let's do a width of cut of 100 thousandths. Okay, the regular RPM and inches per minute would be 22.9 inches per minute. With the chip thinning factor, it's 33.7. Okay, so with the 45 degree, it's 30% increase in chip load, and a toroidal figures out a true effective cutter diameter based upon the corner radiuses there, similar to the ball nose. So there's 4 more advanced calculations in the milling area.